Here we have a SAT math problem. Okay, let's go to the question. The graph of a circle whose equation is x square positive y square equals to 100 is shown in the expression above. If the graph of y equals to x positive k, where k is a constant, is tangent to the graph of the circle, which of the following is closest to the value of k? Okay, here we have to get the value of the constant k that we have in the equation of the line. Actually, the equation of the line over here is in slope intercept form. That is y equals to mx positive b. Okay, here this m represents a slope and this b represents a y-intercept. Okay, at the place of m in the given equation of line, we have 1. That is a coefficient of x is 1. So that is the slope of the line equals to 1. At the place of b, we have k. That is the y-intercept of the line is k. That is the line intersects y-axis at k. So this is the point of intersection of the line and y-axis. So here we have the value k because k is the y-intercept. Okay, here we have origin. Here we have the value k on the y-axis. Then what is the length of this vertical line segment over here? So that is k. And now let's consider the slope over here. That is slope equals to 1. Now we can consider the formula, that is rise over run for slope. Okay, let me write the formula over here. That is rise over run equals to 1. Since the rise over run is equal to 1, the value of rise and the value of run must be equal. Now let's go to the graph over here. In this graph, the vertical line segment over here represents the rise and the horizontal line segment we have over here represents run. Okay, since rise over run equals to 1, rise and run must be equal, then the length of this vertical line segment, the length of this horizontal line segment must be equal. Already we got the length of the vertical line segment over here, that is k. Then the length of this horizontal line segment also must be k. And we know that at the point of intersection, x-axis and y-axis always will have right angle. So here we have a right angle. Okay, so clearly this triangle over here is an isosceles right triangle because here we have a right angle and the length of these two legs are equal. That is k, and this is hypotenuse because it is opposite to the right angle. And also we can mark this is point A and this is point B. Now let me draw a radius to the circle. Let me draw it. Okay, here I have drawn a radius to the circle. This line segment over here represents a radius, and let's consider the equation of the circle. It is given in standard form, and we can write this equation of the circle x square positive y square equals to this 100 can be written as 10 square, and we can consider the equation of the circle in standard form, that is x square positive y square equals to r square. Here at the place of r, we have 10. That is the radius of the circle is 10. That is the length of the line segment over here is 10. And let me mark the point C over here. And this is a point of tangency. That is the point at where the line touches the circle. At the point of tangency, always will have right angle between the radius of the circle and the tangent line. So here we have right angle, and this OC represents the altitude of the triangle because it's a line drawn from the one of the vertices of the triangle to the side AB, and also this line segment OC intersects the side AB of the triangle at right angle. So this is an altitude of the triangle, and this altitude is drawn between the two equal legs of this right triangle OAB. Whenever we draw an altitude between the two equal legs of a right triangle, then the altitude will divide the right triangle into two congruent isosceles right triangle. That is, this triangle OAC over here and OBC over here are congruent isosceles right triangle. Now let me consider this isosceles right triangle over here, OBC. In this isosceles right triangle, this OB represents hypotenuse because it is opposite to the right angle. And the remaining two legs are BC and OC. They must be equal in length because it's an isosceles right triangle. Already we have the length of this leg OC. The same length we have for this leg BC as well. That is 10. Okay, here in this isosceles right triangle, let's consider the two interior angles over here which are opposite to the sides of equal length. In any isosceles right triangle, the two interior angles which are opposite to the sides of equal length must measure 45 degrees each. Okay, so the measure of angle over here has to be 45 degrees, and here we have 45 degrees. Now it's a 45, 45, 90 special right triangle. In this 45, 45, 90 special right triangle, when I want to get the length of the hypotenuse, what I have to do is I have to multiply the length of the two equal legs by square root of 2. That is, this 10 has to be multiplied by square root of 2. The length of the hypotenuse OB over here must be 10 times the square root of 2. Already we got the length of this hypotenuse OB, that is k. So this k and this 10 times square root of 2, both of them represent the same stuff, that is the length of the hypotenuse OB. Then the k and 10 times square root of 2 must be equal. Okay, now to get the value of this 10 times square root of 2, we have to multiply this 10 and square root of 2. Using calculator, I'm getting 14.1421 and it keeps going. Okay, now let's consider the given answer choices for the value of k. So we have to get the one that is close to this value, that is clearly 14.14 in answer choice B. So the correct answer choice for this question is B.